All right. Hello, everyone. Welcome to Pre-Calc lesson 3.4, solving exponential and logarithm equations. Um, so to solve these equations, there's a couple strategies for solving exponential and logarithm equations. The first is rewrite the original equation in a form that allows the use of the one-to-one properties of exponential logarithmic functions. Rewrite exponential equations in logarithm form and apply the inverse property of logarithmic functions, or three. Rewrite a logarithmic equation in exponential form and apply the inverse property of exponential function. So pretty much the same like you learned in Math 3. Solve the equations through logarithm equation. So for this one right here, number 18, just multiply each equation by log. Oops, too big. So log of 3x equals log of 243. Do the power rule. X log of 3 equals log of 243. Solve for x by multiplying both sides by log of 3. So just plug that in the calculator. X equals 5.04. Now, a lot of these, there's more than one ways to solve them. The other way you could solve this problem is also convert from exponential to logarithmic form. So exponential to logarithmic form. So this would be x of log of 3 of 243, and then just do log of 243 divided by log of 3. And that'll give you the same answer, 5.04. So more than one way to solve the equations, but you'll get to the same answer. So exponential to logarithm or logarithm to exponential. The next one, a lot of these I'll just do them the regular way. And just multiply them by log, power rule, and then solve for x. So, oops, getting ahead of myself. Log of 1/8 to the power of x equals log of 64. Power rule. And then just solve for x. So log of 64 or the log of 1/8. Just plug that into a calculator and you'll get -2 as your answer. So nothing too difficult. For the next problem, log of x is 25. This is one where you would have to convert from logarithm to exponential. So this would be 25 is equal to x squared. To solve for x, you take the square root of both sides. Now, when you're finding the solutions, obviously it'll be plus or minus 5. But in this case, since it's a logarithm, you can't have a negative in the logarithm. So this would just be x equals +5 only, not -5, because negative numbers is outside the domain for a logarithm function. So do be very careful. You cannot have negative in the logarithm. Simplify. This one already gives you a hint already. We're going to use the power rule. 2x minus 1, ln of e. Now we do know that ln of e is just 1, so we cross that out. You can keep the imaginary 1, but it's completely up to you. So 2x minus 1 would be our final solution. Okay. For the next problem, this is we're going to use one of the properties, in which case e of ln of x, is equal to x. So in this case, if e11 is x squared, this would just be x squared. So we're just using that property from the previous sections. So we know that e of 11x is just x. Therefore, e11x squared is just x squared. Now, the reason why that works, um, if you want to write out the whole equations for it, so we have e11 of x squared is equal to y. We could take the ln of both sides. Do the power rule. We know ln of e is just 1. So ln of x squared is equal to ln of y. And since they're both ln, they can cancel each other out. So we know y is equal to just x squared. That's just one way of knowing why it actually is x squared. But so number the next one, solve algebraically round to 3 decimals, change to log. So we have e to the power e 6 to the power of 5x equals 3000. So we can convert this from exponential to logarithm. So 5x equals log of 6 of 3000. Then change of base. 5x is equal to 4.468, which after you plug that into a calculator, divide by 5.894 would be your solution. Next one. So log of 8 negative x minus 2. Put it in standard form. Power rule. Negative x minus 2 equals log of 431 divided by log of 8. Negative x minus 2. That'll give me 2.917. After plug it into the calculator, add to 4.917. Divide by negative 4.917. So that would be our solution. Uh, Moving on, almost done. So solve the algebraic equations algebraically round to 3 decimals. So ln of e could also be written as log of e. So that's also a proportion. So in this case, ln of x equals negative 2. So this can be written as log of e. X equals negative 2. Do logarithm to exponential. So x is equal to e to the power of negative 2, which when you plug into the calculator, you'll get 0.135. Next one, logarithm to exponential. So x squared is equal to 10 to the power of 6. And then take the square root of that. which would be x to the 10 to the power of 3. So x equals 1000. Close, almost done. So convert it to logarithm. X plus 2 exponential. Take the square of it, since we gotta get rid of the square root. So this would be x plus 2 equals e to the power of 2, which will give us 7.389. Subtract 2 to both sides. 5.389 would be our solution for the problem. Last but not least, we're going to use our rules of condensing to solve this. So in this case, subtraction. So it's division. X plus 1 divided by x minus 2 equals ln of x. Since they're both equal to L of an x, they will cancel, they get dropped. So x plus 1 over x minus 2 equals to x. We're going to cross multiply. So we'll have x plus 1 times 1 is just itself, 2x squared minus 2x. Solve for x. In this case, we do have a quadratic equation here, so we're going to move everything to one side. Ideally, you want to keep a positive, so we're going left to the right. So we'll have 0 equals x squared. Subtract x, we got negative 3x. Subtract 1, we'll have minus 1. And then we're just going to use the quadratic formula to find the solutions for this. So x equals negative b plus or minus b squared minus 4ac divided by 2a. Plug everything in. 3 plus or minus 9 plus 4 times 1 times negative 1. So it'll give me positive 4. And then 2 times 1, which would just be 2. Then combine like terms. 3 plus or minus the square root of 13 plus 2. So when we have our solutions, we will have 2 of them because it's plus or minus. So 3 plus the square root of 13 divided by 2 and 3 minus 13 divided by 2. So we gotta simplify it. So x is equal to 3.303 for the addition one, and for the other one, we get negative 0.30. Now, you have to make sure you plug into the original equations. Original equation, so that way you'll know which ones are actually solutions. In this case, there's only one solution, which in this case it would be 3.03. This one will not be a solution because when you plug it in, you will have a negative natural logarithm, and you cannot have negative natural logarithm, especially when you plug it into the second part of the equation. So because when you have negative ln of negative 0.30 minus 2 for the second part, this you'll get an error for this. So just make sure at the very last step you plug it in to ensure that it is a solution, because it's not always going to be the case. Other than that, that's pretty much it. That's lesson 4.3. Sorry, 3.4.